Hi guys, welcome to my channel. Today I'm going to take you through how to perform a chi-square test for independence. And if you find this video helpful, I hope you are going to like and subscribe to our channel Online Academy. So with me here I have this question. The table below shows results from a hypothetical survey of patients who stayed in 3 medical wards in an acute hospital. The data replies to a question: did you feel the amount of contact with nursing staff was A, good, B, adequate, C, sufficient? So using the data shown below, perform a test to test if the amount of contact is independent of ward. Use a significance level of 5%. So what this question requires us to do here is to test if there is a link or a relationship between the amount of contact given to patients and the ward which the patients are staying. So it's like we are just trying to see if there is a dependence, if the amount of contact depends on the ward, or there is no dependence, it's just randomly distributed. And the best test we can use for this one is the chi-squared test for independence or association. So to perform our chi-squared test, the first stage is to write down the hypothesis, the null hypothesis, and the alternative hypothesis. So in this case, our null hypothesis will state that the amount of contact is independent to ward. Okay, so whenever you are testing for a chi-squared test for independence, you must know that your null hypothesis must state that your variables are independent, and then the alternative will go on and state that the variables are dependent, or they are not independent, that is, they depend on each other. Okay, or you can write it in other terms like there is association or there is no association. Okay, so if you want to use that term for the null hypothesis, you say that there is no association between your given variables. So in this case, it will be there is no association between the amount of contact and the word, and then the other hypothesis will state that there is an association between the variables. Okay, so that's the first stage. And then next, all right, we are given our alpha is equal to 0.05, that is 5%. The test statistic chi-squared given by that formula, summation of OIJ minus AIJ squared over EIJ, and we're summing from J squared 1 to C and also from I squared 1 to R. Okay, so we're summing over the rows and over the columns, the differences squared over the expected. Okay, and this follows a chi-squared with V degrees of freedom, and our V degrees of freedom, okay, we'll calculate the degrees of freedom later in the video. Okay, so what you are going to do next is to calculate the expected frequencies, our EIJs. Okay, so to calculate these frequencies, we use the formula EIJ is equal to the column totals multiplied by row totals over the grand total. Okay, here I have reproduced our contingency table from the question, but then I've added some space for the expected frequencies. So what we will do here, first of all, we are going to calculate the row totals and column totals, and to calculate this we're just summing across the rows and across the columns. Okay, so here we're going to say 24 plus 27 plus 26 we'll get 67, and then for the second row, 12 plus 19 plus 15. I'm sure this is very easy, this is not going to cause us any problems. So if we sum, you're going to get 22. Then for the first column, word A, the total is 42, and then the next is 55, and then the next is 38. Okay, then we're going to calculate the grand total. The grand total, you can add the row totals or the column totals, they must give you the same grand total. Okay, so here if we add 42 plus 25 plus 38, I'm sure we are going to get 135 is our grand total. Okay, so using this formula to calculate our expected values. For the first cell, we're going to say the row total is 67 and the column total is 42. So we're going to say 67 multiplied by 42 or divided by 135. Okay, so if we say 67 multiplied by 42 divided by 135, if you punch that on the calculator, let's see what we're going to get. Okay, we're going to get 20.8444. okay, then for the next cell, you take the row total, which is 67 multiplied by the column total 55. okay, and we do the same. We multiply 67 by 55 and divide all by 135. okay, and if we do that, I think we're going to get 27.2963. okay, we go on and do the same for the next cell. Here it will be 67 multiplied by 38 over 135. okay, and doing that, I guess we are going to get 18.8593. Alright, then you do the same for the next columns, for the next cells. That is, for the next cell here, we are going to say 46 multiplied by 42, you divide by 135, and then get the expected value. Okay, so I'm not going to waste time calculating all the values. So yeah, I will fill in with 14.3111, then 18.7407, then 12.9481, then 6.8444, 8.9630, then 6.1926. okay, you can go on and calculate these to check if you get the same values. okay, so after filling this contingency table, the next thing we are going to do is to calculate our degrees of freedom. okay, so to calculate our degrees of freedom, which we denote by V here, we use the formula R minus 1 multiplied by C minus 1. okay, so R is the number of rows in our contingency table and C is the number of columns in our contingency table. okay, so if we look at our contingency table here, we are going to see that our table is 1 2 3 columns and 1 2 3 rows. okay, so we're going to say 3 rows minus 1, 3 rows minus 1. Here we get 2 multiplied by 3 columns minus 1 is another 2, so 2 multiplied by 2 we're going to get 4. So our degrees of freedom for this setup is 4. okay, so here you can write your values in a table like this one: the observed, the expected, then the last column for OIJ minus EIJ squared all over E. okay, so we're going to calculate this one for each and every row we have here. So for the first one, it will be something like 24 minus 20.8444 squared all over 20.8444, something like this, and then you evaluate this one to see what I'm going to get. okay, so here on my calculator, I got 0.4777. okay, so we do this for the next values, and if we calculate this one by one here, I'm sure it's going to take us a lot of time, so I'm going to fill up, but you have to follow one by one, calculating and checking if my values are correct. okay, so here I got 0.00322, then 0.4336, 0.3732, and 0.00358, then 0.3252, then 0.1042, then 0.00015, and lastly 0.1053. okay, Okay, and then the next thing, to get our chi-squared, we will sum the values in this last column here to get our chi-squared value. So if we sum this, I'm sure we are going to get something like 1.82615. okay, and then all right, sorry for that. So our chi-squared value will be 1.82615 over there. Then the next thing is our rejection criteria. Okay, we're going to say we reject H naught, the null hypothesis, if our calculated chi-squared value is greater than the chi-squared critical value from our tables. Okay, so here we found that our degrees of freedom here is 4. Okay, so it will be chi-squared 0.05 with 4 degrees of freedom. So we are going to look out this value from our statistical tables. So for a chi-squared with 4 degrees of freedom at 5% significance level, that is chi-squared 0.05 with 4 degrees of freedom here, the critical value will be 9.488. okay, so we are going to compare this value with the one which we calculated in order to come up with our decision for the hypothesis. Okay, so here we said we reject H naught if chi-squared car is greater than chi-squared 0.05 with 4 degrees of freedom. Okay, so here we can see that our chi-squared car here is 1.82615, which is less than 9.488. okay, so which means here with our hypothesis we fail to reject H naught. Okay, so our conclusion here, or our decision, is that we fail to reject H naught. And what does that mean if we fail to reject the null hypothesis? Okay, if we go back, we can see that the null hypothesis was saying there is independence. Okay, there is no association. All right, so what does it mean if we reject the null hypothesis? It means that we are taking the alternative hypothesis, which said there is dependence between the amount of conduct and the word. Okay, so if we fail to reject the H naught, we conclude that there is insufficient evidence to claim that the amount of conduct is independent of what. Okay, so that's how you write your conclusion, that there is insufficient evidence to claim that the amount of conduct is independent of what. So that's our chi-squared test for today. Thank you guys for watching. I hope you are going to like and subscribe to our channel.